This is the first video from 4.2. We're going to talk about polynomial functions. So, a polynomial function is a special kind of function, and we talk about it first because, before we talk about others specifically, because it has a domain of all real numbers. So that's one of the ways that you can remember what a polynomial is because you know for sure the domain will be all real numbers. Alright, so let's look at some possible polynomials, some examples of things that are polynomials and things that are not polynomials. Here's an example of a typical polynomial, okay? It's even written in the standard form, or the general form, where the exponents are in decreasing order. Okay, so the exponents are really important. That's kind of how you tell with a polynomial. These exponents are whole numbers. Okay, so a whole number, not an integer. Remember, integers could be negative. Exponents in a polynomial cannot be negative. And think about it, if you had a negative exponent, that would be 1 over that variable, and that would not have all real numbers for a domain because we'd have a variable in the denominator. So a polynomial has only whole numbers for exponents. Okay, this polynomial is not, this function is not a polynomial because you got this negative exponent. Now this polynomial, this function is a polynomial, so it looks kind of different because there are no variables in it. But the exponent, you could consider this having a x to the 0, and 0 is a whole number, so that makes this a polynomial. There are no negative exponents, right? There are no fractional exponents, so this is a polynomial. A constant function is a polynomial. These two functions are not polynomials. So a square root is like a fraction exponent, right? And this has a fraction exponent here. So that makes it not a polynomial. And the domain wouldn't be all real numbers, right? So polynomials do not have any square roots or any roots, no fractional exponents, nothing. So even though a cubed root would be all real numbers, it still isn't a polynomial. A polynomial has only exponents that are whole numbers. That means 0, 1, 2, 3, 4, 5, so on. No negatives, no fractions. No variables in the denominator. Now this function is a polynomial. So even though there are fractions in it, they are not the exponents. Okay, so this would be a polynomial. All of these polynomials have all real numbers for their domains. The other thing we should know about polynomials is we talk about them in terms of degree. So this first one here, this is a 7th degree polynomial, right? Because the largest degree is a 7. This polynomial is a constant polynomial. We could say that its degree is 0. Because if we did put a variable there, it would be x to the 0. This polynomial has degree 5, so we call it a 5th degree polynomial. And the other thing we should know about polynomials as we talk about them would be another terminology, and that's the terms of a polynomial. So this polynomial has 4 terms. So each of these groups of things multiplied together, right? Each of those things are terms. So this has 4 terms. This has 1 term. When it only has 1 term, we call it a monomial. Mono meaning 1, right? This has 4 terms again. If we had something with just 2 terms, like if we had the function x plus 3, that would be a polynomial. It would be a first degree polynomial because the biggest degree on the variable would be a 1, and it has 2 terms, so we would call it a binomial. If it has 3 terms, like the ones we just talked about in the previous section, the quadratics, they have 3 terms, so they're trinomials. Well, some of them have 3 terms, and they have the largest degree is a 2, so that's a second degree polynomial. That's what a quadratic is. So we want to look at the graphs of some of our basic monomials. Okay, these are ones from our library of functions. Okay, so first of all, the identity function, f of x equals x. So here's what I want you to notice about this. Okay, the exponent is an odd number, right? And look what happens. As we go to the right, it goes up. It's going up to positive infinity. As you go to the left, so suppose you were here in the middle and you're moving to the left, or you're moving towards the negative side, right? The y value goes to negative infinity. I'm going to write that as these 2 arrows here. Okay, down to the left, up to the right. Okay, I left the first degree one on, and I'm showing you the 3rd degree, right? This is our cube function from the library of functions. Look again at this. The end behavior is what we call this. Okay, so as x gets larger, y gets larger, goes to infinity. As we go towards the negative side, the end of the graph is going towards negative infinity. So it's the same. Okay, so the 3rd degree goes up to the right, down as we go to the left. Let's look at the 5th degree. The 5th degree, the same thing happens. And what's going to happen for every degree higher than that, like the 7th degree and the 9th degree? It's going to be the same. If the degree is odd, it goes up to the right and down as you go to the left. Okay, so they're all odd degrees have that as their end behavior. Now, the even degrees, let's look at what they do. Okay, there's our even degree. Now notice the end behavior. As we go to the right on the x, the function gets bigger and bigger to infinity, just like the odd one. But as we go to the left, the function goes to positive infinity. Okay, so we'd say that end behavior is up and up, right? Both of them go up. So I write that like this, with the up, both arrows going up. And I'm sure you can imagine what the 4th degree is going to look like. Right? The 4th degree also goes up on both sides of the equation. It goes up to infinity. Okay, so part of the reason that we look at this end behavior is because when we have a more complicated polynomial, that first degree, the biggest degree, it determines what the ends are going to look like. Okay, so here's a polynomial, x cubed minus 3x plus 1, and it does all kinds of things in the middle here, but in the ends, when we really get to bigger numbers, it's going up to the right, it's going down to the left, just like the x cubed always does. Okay, so this is a third degree polynomial, and its end behavior is the same as x cubed. So that's why we look at that degree of the polynomial, the largest one, the monomial, and that will tell us what the end behavior is going to be, even though in the middle it may do all kinds of different things. The notation we sometimes use for this is to say that y goes to infinity as x goes to infinity. And that would mean that up here, as x goes out to infinity, somehow this is going up, right? And if we said y goes to infinity as x goes to negative infinity, that would mean somewhere out here it's going up, which would happen with any even degree polynomial, right? Now in the middle it might do all kinds of things here, but in the end it will go up on the two ends. Okay, that's what we talk about as the end behavior. So just to review, the things we want to know from this video are what a polynomial is. And remember, polynomial is always going to have exponents on the variables that are whole numbers. So if there's no variable, you can consider that it's x to the 0. That's a whole number. Okay? No fractional exponents, no roots, no variables in the denominator, no negative exponents. All of those are not polynomials, right? And a polynomial, the domain is always all real numbers. So here's your quiz question. I've made a list of 7 functions. I want you to name the ones that are polynomials. There will be more than one. Just list them using a comma to separate them. Okay? So go and put those into Canvas as part of the quiz.